Good day, fellow. Setso is back. Today we are going to continue with the application of Theorem 1. Let's see what they give us. We have O, which is the center of the circle, AB, which is 10 centimeter. They also gave us that OD is perpendicular to AB with the radius of 13 centimeter. Let me indicate the radius. From OA, it's a radius, we have 13. OB, we also have 13. And our OC again, it's a radius. You see? Now they want us to determine the value of DC from this point up until this point. You see? Before we can determine the length of DC, firstly, I just want to highlight something which is very important. You see, we have this theorem, then we write AMBO and its converse, like this. AMBO. Do you understand? You just need to know if now we have a case like this where OM is perpendicular to AB. Therefore, AM is going to be equals to BM. Do you understand? Then the reason that we normally use is this one. Perpendicular from center. Oh, sorry about the light. Perpendicular from center to the chord, like this. Then as for this one, now we have a case where AM is equals to BM. Therefore, OM is going to be perpendicular to AB. The reason is going to be a line drawn from center to the midpoint, of a chord. You see, I just wanted to highlight these two concepts. Then on our given diagram, we have OD, which is perpendicular to AB. Therefore, from A to D, since we have AB being 10 centimeter, from A to D, we are going to get the half of 10. Same from B to D, we are going to get 5 centimeter. Therefore, the reason that we are going to use is this one, perpendicular from center to the chord. Let me erase and write it. Okay, we are going to say now AD is equals to BD is equals to 5 centimeter. Then use this reason, perpendicular from center to the chord. Understand? Like this. Now, let's continue. We need DC. For us to get DC, we must firstly get OD in this case. Then how then are we going to get the value of DC? Check. From this diagram, I'm going to take out O, B, and D like this. We know that this one is 5, this one is 13, this one is unknown. We have a right angle triangle. For us to get OD, clearly we are going to use what? The theorem of Pythagoras, which is as follows. Let me say OB squared is equals to BD squared plus OD squared. OD squared, like this. Then now in this case we have what? We have a theorem. Okay, I don't have much space. Let me write here. We have a theorem of Pythagoras. Do you understand? Now let us substitute. Our OB is 13. We have 13 squared. Our BD is 5 squared. Then we have OD squared like this. Now we need our calculator. Okay, I hope you can see. We have 13 close bracket squared. We get 169 equals to, then we put 5, we get 25 plus OD squared. Then we take 25 to the other side, minus 25 OD squared. We have 169 minus 25, we get 144. 144 equals to OD squared. Let me write it like this. Let me start with OD squared is equals to 144. Now, for us to get OD, we need to take the root both sides. Then our OD is going to be equals to 12 what? Centimeter. You see? Now we know that our OD is going to be 12 centimeter. Bear this in mind, that OC and OB, both of them, they are radius. You see? Somehow they are going to be equal. Then we get a case like this now. OC, which is equals to OB. Both of these are radius. They are equal, you see. But now we know that OC is made up of OD, yes, OD plus DC, which is equals to OB. Yes, ODDC. Yes. You see, we know the value of OD now is 12, like this, of DC. Not yet. Then of OB, we know that is 13. See, OB, sorry, I don't know why I keep on saying OD, but okay. To figure out DC now, we can then say 13 minus 12. We take 12 to the other side. It's going to be DC. 13 is going to be 13 minus 12, like this. Then 13 minus 12, we get 1 centimeter. Then our DC is going to be 1 centimeter, which is true that if we add 12 together with 1, we are going to get what? 13. You see, just like this, we have managed to answer this question. And again, if you are new to this channel, kindly don't forget to subscribe. I thank you and enjoy.